Hello students, I am Jaspreet Kaur and today we are going to study the new concept of the chapter Redox Reaction, and the concept is Balancing the Redox Reactions that we have studied in the previous session. We have different kind of the methods that we can use for studying and balancing the redox reactions. The very first one is the oxidation number method. As the name says, oxidation number method, that means something which is relatable to oxidation number. Yes, definitely. Oxidation number was what? The charge which was present on that elemental atom present in a compound. The charge came due to loss or the gain of the electrons. So, oxidation number method, it will study about the increase or decrease in the oxidation number, and accordingly it helps us to balance that chemical equation. Fine. So, let's have a look about the steps that are 5 in the number for the oxidation number method. The very first step says, please write the formulae of the each compound. We can take the example to study this particular method. Let's talk about potassium dichromate reacting with sodium sulfite, giving us in the acidic medium. So it will lead us to the reaction that will give us sodium sulfate, I would say that, and there is a release of the chromium ions as well. Clear? It would be leading to the formation of the chromium ions. So the very first step, writing the formulae, rather than writing the complete formula, it's always best to write the ionic form of the elements. So here I can write Cr2O7 2 negative for dichromate ions, SO3 2 negatives for sulfite ions, SO4 negative 2 negative for sulfate, and Cr3 positive for chromium ions. Clear? The second step says, identify the atoms that undergo change in oxidation number. So first of all, for that we need to write the oxidation number. Let's have a look for dichromate ions. When I have 2x minus 14 is equal to minus 2, 2x is equal to plus 12, x is equal to plus 6. We have done this particular method in the previous video where we learnt how to calculate the oxidation number of the given element present in that compound. So here we got it's plus 6 oxygen minus 2. For sulfur we can again find out, that is the x, and we have minus 6 and minus 2. X, it comes out to be plus 4. So here we have plus 4 and minus 2. For sulfur over here, again we can calculate, that is x minus 8 minus 2, we have plus 6 over here. So here it is plus 6, here it is minus 2 for oxygen, and chromium 3 positive. Fine, so we have written the oxidation number. Now we have to identify the atoms where there is a change in the oxidation number. So chromium as well as sulfur, we can easily see that there is a change in the oxidation number. Chromium and sulfur. Now calculate the increase or decrease in the oxidation number per atom. First of all, let us know what is the change. For chromium, before it was plus 6 and after it came to be plus 3, so a change of 3. Fine, a decrement to the 3. Then we have sulfur with the plus 4 before and plus 6 later on, so change of plus 2. Clear? Next one is multiply on either side to equalize. So we have to equalize. Here number of chromium atoms are 2 and here we have 1 chromium ion. So we can balance it first of all. So to balance this one, we can multiply this particular one with 2 so that we have the equivalent number of the chromium ions. Moving towards the sulfur, let's have a look towards the number of oxygen atom. So multiplying it with 3 and 3, let's say, does it work out in the further reactions? If it does not, we will change it. Fine. We have next, add on H positive ions if it is the acidic medium, if the reaction has taken place in the acidic medium, and OH negative if it has taken place in the basic or the alkaline medium. So in the beginning I told you people that this reaction is occurring in the acidic medium in the presence of the H positive ions. So here what I will do, I'll add on the number of H positive ions. So that H positive has to be added to the right hand side. Clear? So it must be added to this particular side, H positive. Clear? So H positive added to this particular side. Now we have to find out how many H positive we need to add. That will depend upon the number of oxygen. Because in the next step they say that to equalize the hydrogen atoms we need to add the water molecules. So let's equalize the these hydrogen atoms. Okay, so here we have 12 molecules of the water, here 6, here it is 1, here we have 7, here again we have 9. So total they were 18, total here we have 16. Clear? So total of the oxygen atom that are 16 over there, and here one again we have 19. We can do one thing, we can add on the even number. Let's check it out with the number 2. If I am adding 2 numbers, here it will be 2 molecule of the H positive. It is not the balanced chemical equations, we have already checked. With the number 3, I have to add it on over 2. That means the number of oxygen atoms that were 18, here it will be 20. And here again the number has remained 2. We could say that 16 only. Let's check it out with the 4. With the 2 only. Here number of the water molecules, that is the 2, and here with the 4. Again we could say that there is a unbalanced chemical equation. So scientists they developed this thing that multiplying this particular one with the 8 H positive ion, taking here over 4, now add on. That is the 12, clear, 6, and this one was the 4. Total we have 22, here we have 7 plus 9, which was 16 in the number. Now both of these are the even number of the atoms. Secondly, since these are present in the ionic form, we have already seen that. So it's okay to have this particular number. 8 was the number which was actually acceptable in this particular case. So here 8 H positive ions, it are neutralized by the 4 molecules of the water. So we could say that yes, in this particular method, to equalize the number of the H positive ions, we require 4 molecules of the water. This was the method with which we can easily find out the, we could say that we could easily balance the chemical equation. If we will check completely using these oxidation number, the ions which is on the polyatomic ion that is present, the charge which is present over there, we will find out that the number of the oxygen, sulfur, chromium and the hydrogen atoms, they are equal in the number. There was the change that was coming over here. It is only because we were taking it in the ionic form. Clear? So that was all about the oxidation number method. We have with us the another method, which is the half reaction method. The half reaction method, as the name says, we will carry on the reactions in the 2 halves. Fine. So let's have a look. First of all, the half reaction method, we have taken the iron ions that are being oxidized from the ferrous to the ferric in the presence of the dichromate ions. And this reaction is again occurring in the acidic media. Clear? The very first thing that we need to mention, first of all, we need to write the ionic form of the compound. Ionic form over here, we have written, if we have the iron salt or any oxide of the iron, we have taken the ferrous ions, then dichromate ions. They are reacting with it in the presence of the H positive ions to give us the ferric ions and the chromium ions. Clear? The very first step is whatever the compound is available with us, we must write that in the ionic form. Secondly, the oxidation, we have to write the reactions in the 2 halves. First of all, the oxidation half, the other one is the reduction half. What does that mean? Oxidation half reaction means the reaction. The species which are undergoing the oxidation, their oxidation half reaction. A reduction half, the species which are undergoing the reduction, that is the gain of the electrons. Let's have a look. First of all, here ferrous is converted to ferric. When there is conversion from the +2 to +3, definitely that is an oxidation. So this represents the oxidation half reaction. Clear? From the Fe2 positive to Fe3 positive. Moving ahead, we have the reduction half. That means reduction is usually what is there? Decrease in the oxidation number. Fine. So when we have the decrease in the oxidation number, here we can check it out for the chromium ions in dichromate Cr2O72 negative 2x minus 14 minus 2. We have find out in the previous one as well, it was plus 6. Fine. So here it is the plus 6, here it is plus 3. So there is a decrease in the oxidation number, hence it justifies the reduction half reaction. Then the another step says, let's balance all the atoms except hydrogen and the oxygen. Now please have a look, which one needs to be balanced over here? It's only the chromium ions that needs to be balanced, because here in the dichromate number of chromium atoms are 2, but in the chromium ions we have just one chromium ion. So we need to balance that. So we need to balance this with 2, because here the number of chromium atoms in the dichromate ion are 2. So we have balanced that with the 2. Moving ahead, the next step, let's talk about it. Moving ahead, we have the next step that involves the addition of the H positive ions for the acidic media and the OH negative ions for the basic media. So we will be there to add the H positive ions to this dichromate ions, fine, and we have already balanced this one in the second step over there, and here we have the number of water molecules, because the equivalent number of water molecules are produced on the right hand side. So here to balance the equation we have taken the number 7 and here it is the number 14. Let's move ahead with the next step that says add the electrons to the one side of the half reaction, then balance it on the other side. So because we know that this was the oxidation that has taken place, so iron, it loses one of its electron to change from the ferrous to the ferric form. Now in the next step what we have dichromate ions plus 14H positive and 6 electrons. Now why these 6 electrons are added? Because if we all together add on, till here if we will add on the positive charges, you will find they are 12 in the number. On the other hand, if you will add on the positive charges, that are 6 in the numbers. Just to balance that thing, we are adding 6 electrons so that the positive charge, which is 12 in number, it is neutralized with these 6 electrons. Clear? Just add on these positive charges, you will find the total, they will become 12 in the number. So here it is balancing that. The last step says that balance both the sides. When we have balanced both the sides, we will have Fe2 positive plus dichromate ions plus 14H positive and 6 electrons. Moving ahead, we have 2 chromate ions plus 7 water molecules. And we had the number of electrons over here, that was the 1. We can cancel these electrons which are present on this side and with the electrons which are present over here. So this is the one which gives us the balanced chemical equation. Clear? So that is the one exact chemical equation for the same. Here we are left with the Fe3 positive ions only. Is it clear? So that is the final equation. That was all about the half reaction method. I hope it's clear to you people that how we have gone through the different steps to find out the, we could say that for balancing that particular redox reaction. So that was all about this, I would say that half reaction method. So we are left with the last topic of this particular chapter, that is the redox reactions and the electrode processes. We did one experiment in the beginning where we studied about competition in the electron transfer reactions. So competitive electron transfer reactions where we had zinc rod, copper sulfate solution leading to the formation of zinc ions, and we had copper metal. We could say that here it was zinc sulfate. Clear? I hope you people remember that we have done this thing where we have taken the beaker. In that particular beaker, we took the copper sulfate solution. There was the zinc rod which was dipped in it. Fine, it was kept for for some time period where we later on observed that this zinc, this rod, this strip, it was actually coated with the copper metal. So in this particular reaction, what has happened that zinc, it was oxidized to the zinc ions and the copper, it was reduced to the copper metal. This was a particular reaction where the involvement of the ions, or we could say that the formation of the metal or the formation of the ion took place in the solution form. There is another way for the same. For example, I have two beakers. one containing copper sulfate, another containing zinc sulfate, clear, with the rods dipped in them and the reaction occurring there. What will happen if I am dipping the rods of the copper in the copper sulfate, zinc in the zinc sulfate? What will happen after some time period? They will form a kind of the couple which is said to be redox couple. There leads to the formation of the redox couple. Redox couple is what? Here I have the copper sulfate solution and this is the copper metal. Now the reaction is taking place at the interface of metal and salt solution, which is copper sulfate solution over here. Here it is the zinc sulfate, clear, and zinc. So the reaction which is occurring at the interface of zinc and zinc sulfate, which is a salt solution, it will lead to the formation of the reaction, a kind of the couple which we call the redox couple. Now what do we mean by redox couple? Redox couple means these species are simultaneously oxidized and reduced in the half reactions, in the given half reactions, in the oxidation half reaction and the reduction half reaction, these species, they are getting oxidized and reduced. Hence, they lead to the formation of the couple which we call the redox couple. If I have to present the redox couple over here, I'll say zinc 2 positive and zinc. If I have to write about here, copper 2 positive and copper, a slash is there to represent a couple. So this is the copper couple, this is the zinc couple. Clear? Moving ahead, there is a third way of performing the same experiment, which is as follows. We have the third method for finding out the electrode processes and the reactions. It is connecting with the salt bridge. Here, till now, we studied about different solutions. Firstly, we had the copper sulfate solution with the zinc rod dipped in that. Later on, we took copper rod in the copper sulfate, zinc rod in the zinc sulfate. Fine. Now we have a salt bridge which is connecting the two different solutions. They are not directly mixed with each other. What we have done in the one beaker, we took the zinc sulfate and the zinc rod. In the other one, we took the copper sulfate and the copper rod. Clear? Now, these solutions, they were connected with the help of salt bridge, which is potassium chloride here. Salt bridge, it helps to provide the connectivity of the one solution with the another. Here we have the different rods which are acting as the electrodes. These rods, they are said to be the electrodes since they are connecting, they are making a electrical connection between the two rods. So this particular rod is said to be anode since it is negative, it is having the negative charge on it, and this one as a positive charge, hence the cathode. Positively charged electrons. Why? We will check it out why this is anode and why that anode. Since we have this one as the zinc sulfate solution and the zinc ions are formed, it means cations are formed over here. Cations will definitely move towards the cathode, which is the negatively charged electrode. So here there is a movement of the positive ions. Cations, they will move to that side. Anions, what are that? That is the negatively charged electrons which will be moving from the anions, they will move towards the anode. Clear? So we know that there is a formation of the zinc ions, therefore there is a movement of the current that takes place through the help of this metallic wire when there is a connection that is being built up. This current will only move when this key is locked. Till now this is opened up. When this key is open, this circuit is not complete. Till that time period, there will be no current that will be moving. But once this circuit is locked, this key is locked, there will be current that will be flowing in that particular medium. There will be transfer of the ions from one rod to the another rod. Clear? Now, in the beginning, there was the potential which is associated with these two rods. These potential are said to be electrode potential. Fine. And there is a one term which is known as the standard electrode potential. Standard electrode potential means when there are the standard conditions, we are taking the concentration of these species as unity. Clear? That is the equivalent to 1. Fine. Then we had the temperature, which was 298 Kelvin, which is the standard temperature. We had the pressure, which was 1 atmosphere. Under those set of the conditions of temperature and pressure, it was checked that the electrode potential which is available there, that is the standard electrode potential. Fine. So there is one important thing which is associated with it. The more negative value of the electrode potential, clear, the more stronger is the reducing agent. And we have studied about the electrode potential. Standard electrode potential for the hydrogen, it is 0 electron volt, or it's 0 volts, we could say that. So this was all about the redox reactions, the electrode processes, and we have talked about balancing of the redox reactions in this particular video. I hope the lesson is clear to you people. It's very important to understand this chapter from the perspective of balancing the redox reactions and the different kind of the reactions. That's all for the day. Thank you so much.